So, but, I mean, today, well, you read this, right? All the fine print. I give you 5 minutes, to understand everything that's there. This talk is about what we call enterprise technical debt. So we called it that, so just because we did a lot of work with big organizations across many projects and doing design reviews. So we had a talk yesterday about iterative design reviews at scale, so whoever was there got the background here. But in that design reviews, we do whatever you would do in a design review. You look at the design, you check if that fulfills whatever the organization needs, and if there is a mismatch, then that's a risk, and you write it down as a risk. That's what we did over many projects. By doing so, we discovered that there are some of those risks in there that had very particular properties, which basically led to that they cannot be resolved. So, as you probably know, some of risks will always end up as technical debt. That's just normal. So in the meantime, we understand that. But we had some of them that could not actually be resolved because the impact was on an enterprise level. So we started looking at them and trying to understand what it is and actually, what can we do to make those disappear. In that talk, we cannot give you the solution for it, how to deal with it, how to resolve those. We are not at that point yet. So far, we understand what it is, we understand what the impact is, and we understand what kind of infrastructure we would have to set up to force some actions to resolve those. But that's the point where we are. So maybe in a talk in a year or two, we can provide more insights here. So for now, we will start looking at just trying to get your head around what actually is that technical debt? Why is it special? How would I recognize that we have something like enterprise technical debt? So to get there, let me just briefly talk about organizational structure. Because there is the distinction between what a project is and what the enterprise is, which is kind of like in that picture. So it shows the organization we are working with. It has an operation and maintenance part. Those are the people who run the systems and the applications, and they fix those applications, do the maintenance part of it. And we have some kind of like, on the other side, special projects. Those are usually new things that happen. And all the business knowledge, so the product owner, application owners, sit here on the business side, so the business managers there. Everything that's green here, and what you see throughout the slide, so everything you see something green, we refer to that is the enterprise level. So these are the people that have responsibility across multiple projects. They have to make sure that the organization by itself can actually do what needs to be done. What is blue here, those are the project level people. So the organization has many applications, many projects that sort of like work all together. And in the blue level, there is a single application, a single project, where they add new features, do modernization, whatever that might be. So throughout the presentation, we'll keep that color schema. So when you see something green, it means enterprise. When you see something blue, it means project. So what did we do? So our role was just go across. So the whole organization has a goal saying we need to get better in how we develop our systems. The quality of our systems need to get better. We need to be able to faster create or react to whatever happens in the outside, to give the right tools to our people. Yeah. So in that organization, our job is to make that happen. Although the organization is stovepipes, so basically everyone does whatever they want to, and the organization does not have developers. They use contractors. It's a government organization. That's the way how government has to work. It actually is a mandate. So we have people who want something in the organization, and we have a bunch of contractors, different ones, not always the same one, different ones. So with different backgrounds and different tools and different ideas and different ways how to do things. But all of them somehow need to be organized, orchestrated, that they do whatever is good for the enterprise. And of course, that organization recognizes, as you probably can imagine, that it's almost an impossible task. It doesn't work. So our job is to go to all those teams and little by little move them into the right place. And because we did this, going into the teams, helping them to go the right way, doing the reviews, finding out what's wrong, trying to give them the right direction, we were in the prime location where we actually could discover all the technical debt that is there in all those systems and what the impact would be on the enterprise level. So we went there in a prime location. So just in case that you're not clear what technical debt is, here is the definition that we usually use. So it's in software intelligence system, technical debt consists of design or implementation construct that are expedient in the short term, but set up a technical context that will make future changes more costly and impossible. There is an implied decision here. So if there is a decision that say, I will do something in a certain way to get a short-term gain. And yes, I am aware of that in the future I will have to pay for it. This is important because here is actually explicit decision. And when we look at the technical debt on a project level versus enterprise level, we will see that here is a big difference in what is the properties of enterprise technical debt. So again, upfront, so just to know what we found so far. We see that one thing is the same. Technical debt says there has to be some system artifact there that we can point to. Yes, and for enterprise technical debt, yes, you can do that too. There is a system artifact you can point to. So that's the same thing. The difference come into play here that we actually see that the impact that this technical debt has goes across multiple projects. It's not limited to one of them. It's typically several projects, several applications are involved in here. And it has a quantifiable effect on management level, on enterprise management level. Meaning, to say what's not there, it not necessarily has a quantifiable impact on the project level. Meaning that on a project level, the people may be just fine. They may be just happy, saying, oh yeah, works are fine. I don't know what your problem is. The impact is on enterprise level. Someone else gets hurt here. Someone else would have to pay for it. So there is the big difference. Other characteristics that we see here is to fix it, it usually involves the enterprise management, not the project management. So if someone says, okay, now, we understand here, there's something that needs to be fixed, the projects can't do anything by themselves. Someone on the top has to say, okay, so we have to allocate money for it, may even have to change organization's goals somehow to make certain things happen. It requires project resources to fix. So the fix cannot be done on the enterprise level. The fix has to be done on a project level. meaning now 1, 2, 3, 4 projects have to do certain things differently. Things that don't really like to do. But they would have to do that for the enterprise to get better. So instead of going to the local optimum where every project tries to do, they have to go to a global one, which means that some projects have to pay for it. There is typically a conflict with enterprise goals in there, or standards, and the impact has a ripple effect across multiple projects. So that's what we discovered. Now let me go into the details. Let me talk about 3 examples to try to make it clear what the properties are. Concrete example that we encountered where it happened. So we'll talk about use of a shared data schema, business logic confusion in the MVC framework, and decentralized access control. So let me take the first one. Here was the problem. We have 2 teams. They need to share information. 2 teams that work separately. Each team has their own goal. It just so happened that one of the features that they need to implement requires that they have to share information between them. So I was thinking about, okay, how do we do this? There is an easy solution for it. It's just saying, okay, well, you just get my data. To do whatever you want with it. Or there were other possibilities like, well, we could create an API. So we can talk to each other and exchange information with each other. So for money reason, they decided, let's do it the cheap way. Here's my data schema, use it. Do whatever you want with it. So we ended up with something like this. So we have one application. Each application has their own database with their own data. But there is a piece of data in application A. That's the information that needs to be shared across. And the approach here is, well, just get it. Connect to my database and get the data in here. So that means, going back to our definition, there exists a system artifact. It is that shared data here. And the impact is across several projects. In that case, we have 2 of them. But there's also somewhat envisioned in the future that, well, there might be other applications that may have to connect here too and would need to get that schema. So there is some kind of like thought about accumulation coming up in the future. Not sure yet it would happen, but possible. So what happened here? So from the impact perspective, there's one goal in the organization saying we have all those old systems. We need to modernize them. So one of the modernization is actually about data schemas, because the pattern that I showed here, they use that very often. So instead of talking about API and agreeing on some kind of a contract, saying just connect. With all the impact that there is, then if one team now changes something, it breaks the others, and they don't necessarily know that they have to talk to each other. So the one that are impacted, you see the green ones, those are the people at the enterprise level. They have the problem. The people in the project don't really have a problem. So after you implemented that, so what's the problem? It was quick, it was cheap, no problem there. It will come later, when the team start to change something. Then they will start screaming. But for now, there is no problem. So why should they be unhappy? It's the top people that are here. So the quantifiable effect is on the enterprise level. And it's a conflict to the enterprise goal. The enterprise wants to modernize, to get away from this direct connection to the data, to get to a service API infrastructure picture in that direction. Creating a new system that has a direct connection to the database goes completely against that goal. But again, why would the project care? It's not the project goal. It's an enterprise goal to do so. For the project, it means more work. It's way easier to connect to the database. So there is even, one of the project owners even explicitly said in a meeting, why should I pay more for the other team so that the other team has an easier life? That was the one who owned that schema. So you just connect to it, so I don't have to pay anything for it. I don't care for the other team. I'm not responsible for that. My money is for my project and not for the other ones. So if the other project needs more money, more people, more time, I don't care. So that was actually explicitly said. So therefore, on that project level, there is no way that anyone would say that's technically deadly there. They're actually happy with the way how it is. Second example. How many of you know Spring, the Spring framework? Oh, okay, a few. So one of the goals when the organization started talking about modernization was that also we need to agree to have some way how we structure our software. So at least to have something like where we can separate the UI from the logic from the data. So three-tier application, three-tier good thing. We want this. So we started looking at saying, okay, so how about we use Spring? Spring provides implicit pattern for MVC that would allow us to separate the UI from the logic from the data in there. So it comes with the framework. So which is kind of like cool and easy, and saying, yeah, okay, so every project just uses Spring and that should solve the problem, right? Well, not quite. It may solve the problem if everyone in the project or over all projects actually knows exactly how to use all the components from the Spring framework. So for example, Spring has something like a controller, something like a server, and something like a repository. Those are the controller is a connection to the UI. The service is where the logic sits, and then the repository is where the data comes. So when we look across the projects, we see all types of misuse of that, where they place certain information. So one project, for example, says, well, I have a controller, I have a server, they talk to each other, so, well, yeah, I can do some logic in here, and I can do some logic in here, so it works just fine. Which in many cases lead to that the controller all of a sudden now has to get data and connects to the repository. That works fine. I mean, Spring doesn't prevent you from doing this. So every project can say, we conform to the business goal. We use Spring, MVC, that's what we do. But we still have the problems here that what we try to achieve to get the independence of UI changes and data changes from the logic is in jeopardy here. But again, if you look at the project, every project is happy. I don't know what your problem is. I do exactly what you told me to. Here it is. They just used it wrong, but they don't really have a problem here. So, meaning here, I have to speed up a little bit more. Again, who is impacted here is the business. Their goal that they have, we need to achieve, that we can easily change it, is not fulfilled. They have the problem, not the business side. So it's the enterprise goal that is in jeopardy here. Let me just skip over that. Third example, decentralized access control. Problem here is we have many applications in that organization, and of course every application needs access control. Yeah, that's clear. So which user can do what with that system? And since we are organized in kind of like stovepipes, every developer of the application says, here's what we need. And every developer implemented them themselves somewhere. Some of the access control is role-based. They're saying, okay, if you are a supervisor, then you can do these features. And typically implemented in the code. Some are even organization-based, saying if you are part of this organization, then you can do this and this and this. Some are permission-based. If you have the permission to do this, you can do this and this and this. So everyone does whatever they want to, and of course they get exactly what they want to. So when we do the review, we are only scratching our head and saying, okay, so here we go again. Yet another access control that we have. So, but for the project, they say, no, I mean, these are requirements. This is what we did, and this is exactly what our users need. There is no technical debt. Everything is just plain okay here. No problem at all. The problem comes in now that those damn users, instead of just working with one application, they usually work with many applications. So that means every user in every application has to have an identity. And now, of course, those damn users, they change their work, or they quit, or they retire. So now I have all the identities in all those systems, and no one can figure out anymore if someone changes the position, what does have to change here? Again, that's the enterprise problem. It's not an application problem. The enterprise has the problem now with those users. So better way is just hire them, give them one position, and there is where they stay. They will not be promoted. They cannot quit. They just do whatever they need to do. That would be cool. Easy to handle. So the enterprise has the problem. Again, it's the enterprise managers that are there, and the impact is on the enterprise level. And now I will give it to the good cop. Now that I was doing the bad thing.
Oh, okay, now I'll fix it. I'll fix it. It's okay.
Cool. That's your job. Fix it.
I'm the fixer. There's like a yelling competition between the guy next door, so this is going to be... Do you notice that? It's super loud. All right, okay. Use my big voice, my big girl voice. Let's see if I can do that. Put this close up. Close enough. Okay, can you hear me? Over the guy that's next door. Okay, great. So let's see. So we skip this guy. Okay. All right, so my piece is, what's our time, 15 minutes? Managing technical debt. Okay, so we've just gone through the process of defining some of the characteristics of technical debt or enterprise technical debt. And then we've also talked about some of the examples of enterprise technical debt. So the question is, what do we do with these? So this is the piece where we just talk a little bit about what we're doing with them and how that's working out. So this is a simplified view of our sort of meta model we have for managing enterprise technical debt. So I'll sort of walk you through this. So yesterday we talked about, if anybody was in the session yesterday, let me just show of hands how many people were in the session yesterday. Okay, I have a fair number. Okay, so we're conducting all of these incremental design reviews for about 14 projects, and there are multiple increments within each project. So we're doing a lot of these across a whole lot of different contractor and project environments. And so as we're doing that, we're starting to notice some of these enterprise technical debt items that are not, like Felix said, problems for the particular projects themselves, but we can tell that they're going to be big problems for the people who are paying us to be there and help the organization. So for example, let's take the distributed access control. So starting down here, we're sitting in a project design review, and the project says, we say, well, you know, what you have all of your access control information kind of stored in a schema over here. We noticed that the last design review we were in, another group had it stored in their own schema over here in totally different format, different way of dealing with it. And oh, by the way, the last three we've seen are doing it a completely different way, access control information spread all over the place. But of course, the project says, you know, not a problem. That's not a problem for us because it works fine for us. I mean, we can do what we need to do. So what do we do with that? We consider that basically our discovery process. We're kind of just listening for these things, and we know that that's not going to end up being a project risk. We're not going to put it in the project risk shoulders. We capture that as an enterprise technical debt item and store that data. Then we use that. Basically, we take that, and for the last 6 months ago, we did our first iteration of this. We take that and that information, the technical debt, enterprise technical debt items, and we sort of summarize those, and we take those to the executive management, so the director of IT, director of O&M, and we meet with them face to face, and we pull out the information we have about the enterprise technical debt items. We sort of try to summarize it a little bit for them to make sure that they can see the impact. And then what we're hoping to come out of that is some investment that needs to be made because, like Felix said, the actual projects end up having to do the work. However, the organization has to decide they're going to set aside the funds and allocate that work to the projects. So that's at the executive level. They have to decide they're going to do that funding. And then they actually have to then direct the projects to do the work. And they're always going to have a ton of features to be working on. They're always going to be full up. So they have to have, the executive management has to come in and actually say, hey, you must re-swiggle your backlog and fit that work in. So that's sort of the basic flow there. So let me just mention here, these dog-eared pieces, these are actually views that we keep and we create. And I'm going to talk about those in the next section here. Trip over the thing. Okay, so a key thing that we learned both on the project level as well as the enterprise level is let your data speak for itself. If you can make data visible, extremely powerful. You can go around, stomp your feet all you want, and we do it all the time. We get on the soapbox about having the centralized access control. We have a variety of things that we are just constantly squeaking about, but that doesn't matter. We have to actually bring the data together to actually make a story. So that's what the next piece is about. So we actually have a dashboard that we use for this organization that has two levels. We talked yesterday a little bit about the project level. So we keep track of project level design risks and things like that. Here, we also keep track of the enterprise technical debt items. So I'm going to give you a couple quick views. So this is actually just an example from the project list risks. And these are project project risks that we encountered, just a snapshot of those. And within these, a lot of times, you can see the symptoms of enterprise technical debt. So we mine this data for sure, looking for places where we can see across multiple projects, they're starting to feel the pain of this. They say it's not a problem, but we can kind of see it in the project risk data. So that's actually important data for us, for mining them. And then we also keep a dashboard. I talked about this a little bit yesterday, where we kind of summarize the project level risk. And then the enterprise technical debt list, like I said, this is a completely separate list we keep. It's targeted specifically at enterprise level technical debt. So, you can see in here, here's our, well, there's a couple here. Here's our friend that Felix just talked about having the dependency in the Spring MVC framework between the UI and the data layer, data dependencies. So we actually keep a raw list, nothing too exciting there. But we actually do roll that up, and we share that with the organization so that they can start to see how many of these things are accruing and what projects they're accruing on, or where do we see the symptoms. So we actually keep track. I just called it technical debt here, but enterprise technical debt, we keep that here. And if it's associated with a project, which project it's associated with. And then we will take the data in the last presentation that we did with executive management. We took the data and sort of organized it so we could sort of strengthen our case. So for example, when we sort of do an affinity tree of the data, we can start to see that multiple projects were starting to have these issues of, hey, I would use an centralized access control, but I don't have it. So we're starting to see that we see a lot of enterprise technical debt showing up in the data exchange service API area. There are runway components that need to be created there that would allow for data exchange. There are APIs that are missing both in the internal and the external area. And so we picked up on these as we're doing the design reviews, and we're just putting them in. This is just an affinity grouping of the entity enterprise technical debt. But what we can say then is we can say, hey, if you're going to invest in something, this is an area where there's kind of a big problem, and it's continuing to build. And so we need to look at that, and we need to look at it from the internal and external perspective, which is what we did actually get success in getting them to move out on. So one of the results of this is the organization is now putting in place a secure gateway that actually does some enabling across classification boundaries. That was one of the sort of success stories because we actually were able to motivate by having some of the data that we have. Sort of closing slide here is, why does this matter to architects? Why do you guys care about this? So this is a more elaborate version of our process, and it actually is a little bit more complex. We went through this a little bit yesterday, but the way it works is we do architecture design reviews of system architectures. Out of that, there's a decision that needs to be made of, do I have a design risk or not? And from there, we may decide, and we may see symptoms, that we are also looking at an enterprise technical debt item. So we make a decision that we should actually document that, capture that, and then we push that up to the enterprise, and this is like the management level. We push it up to them, and we try to get them to invest in making a change, which actually, in turn, impacts the system architecture again, because once that new access control comes in, the teams are going to feel it, they're going to have to help build it, and they're going to have to use it. So it actually is a full circle. The driver for this is really the architect team, and that's really what we are. We're the drivers. So it's not going to happen if the architect's not full on behind it, capturing the data, and actually advocating for making the change. And that's where you get the impact. Okay, let me just make sure to check time. 10 minutes, okay, great. Perfect. So, one of the things we learned is that, the more evidence you have, the better your case, the stronger your case, and this is where you can really make the biggest impact is when you do have good, strong evidence and you can really convince them to move out on making an infrastructure, software architecture, infrastructure change that impacts and supports multiple projects. That's where you really make an impact across an organization. So the role of the architect is always to be looking for that, and our ears are tuned toward it in the design reviews, as well as just we attend a lot of status meetings, a lot of things, they bring us into a lot of conversations. We're just always, our ear is tuned to hearing for it. And as we hear it, it progresses through different stages. So in the early stages, we might be like, well, we're not sure if it really is an enterprise technical debt item. It just might be something that's somebody's squeaky wheel over here. But as we start to get more evidence, we put it on our list, and then we start to think, okay, let's kind of listen for that. And then we start to hear more evidence, and we document that, capture that in our repository. So, good, we're ending early. So in this presentation, we talked about the characteristics of enterprise technical debt. We talked about the fact that it typically doesn't have an owner. It often has an implication or an impact on multiple projects. And it requires, though, the projects to actually get involved and help fix it. And it also requires the enterprise to actually take ownership of it and be the champion and invest in it. So those are some of the characteristics. And one of the interesting characteristics also is that enterprise technical debt is typically in conflict with an enterprise goal that they have. So that's one of the reasons it's kind of hard to get anyone to take ownership or do anything with it, because the projects have their own goals at their own project level. That's fine, but it doesn't impede their goals. We only have to be, we are the ones that see it, because we're the ones that are sort of trying to push forward the enterprise goals. We talked about the importance of data visibility and making sure that the more data you have, the better you can build your case and credibility for your case. And we talked about the architect's goal and continuously monitoring and mining the data for it. We also talked about, or let me just tell you where we are in the process. So I told you that we went, the last review we had with our client, we have these kind of big status update reviews every 6 months. The last one we did, we took this data for the first time to them and showed you some of the views that we went over with them. And actually having the data that we had was actually very helpful in building credibility for getting action. And we, one of the big wins, like I said, coming out of it was they are moving forward on a secure gateway, which is just a massive improvement from our perspective. And there are several others that were hot on the heels. I'm going to be bossy and continue to be bossy, but I can be bossy with my data now. So we're just going to continue to be the loud squeaky wheel on those things. So I guess we have a couple minutes. Questions?
Thank you very much.
Thanks.
We have 5 minutes for questions, so.
So you were emphasizing data. Like in the table, you were describing the impact as being basically cost to deliver, a maintenance cost. Are you trying to use some data to quantify the impact of that maintenance cost, or are you asked for that kind of, numerical data or quantifiable data?
You know my response.
Well, first of all, in that organization that we are working with, cost is actually not an argument for them. So we cannot come and collect cost and saying it will cost you this. The argument for them is speed of development, speed to put new features into system. So that is the argument that we use. And yes, we say, so because of this, your ability to put new features into your system is impeded by it. But yes, of course, there is something, we cannot really quantify, put a number in there for that speed. We can only say, well, it probably will cost us for the next year 1 or 2 features not implemented, which of course creates a whole uproar, saying, what? I need 100 features, I only get 10. And now you're telling me from those 10, I can only get 8 for it. So that is the motivation. But there is also, and that is taking the responsibility. Even if you go in there, so you try to get an action to fix something, and yes, sometimes the decision will be, no, we won't fix it. That only means you either are wrong, it's not really technical debt, or you did not collect enough information for it. So if you are still convinced it's technically that something has to happen, take the time, go through all the projects, look for it, look for more evidence. So make the case that it's not just that project that has to do 2 features less. The other 3 too, Now you start to make an argument and saying, oh, wait a minute, that means now, I don't know, 10 features not implemented. Yeah? The answer?
So I have another question. Talking about overcoming resistance of the project teams, right? Especially my experience in organizations that are applying agile principles, much of the mandate for making these kinds of decisions is sort of distributed to the local level. And you mentioned being bossy. So I'd like to hire you, because in my experience, that's a big problem. Organizations have spent years trying to decentralize some of the mandate for these kinds of decisions, and now we're starting to tell them, no, but this you have to do. Yeah. And so how do you overcome that resistance at the local level?
Yeah, so we are lucky because we actually work for somebody who's the director of IT, but well, we're lucky, but we also forged this relationship. We realized very quickly that we had to have the O&M manager backing us and supporting us along the way, because he's the core for he manages all of the projects underneath. So we embraced him immediately, and he comes every Friday to a weekly meeting where we show him the implications of the mess that's being created in his environment and what needs to be fixed. And having him be a champion and back us and help us has been huge. So we sought him out, and we've just really managed that. We've tried really hard to manage that. Really, if there's anybody who has any influence, that's ours. And I will say too, from a perspective of motivation, I kind of stay a little away from cost arguments, because everyone can always poke a hole in an assumption. But when you show an architecture diagram that shows, things like access control data all over the place, immediately, even people who aren't very knowledgeable will start to bristle and get nervous. So I think the architecture, staying focused in the architecture and showing the implications in the architecture, is actually pretty powerful for us. So sorry for so long.
Thank you very much.
That's it.
I think it's time to go to the next speaker.
Sorry, Paulo. Let's have a talk.
Thank you very much.